Chapter 26 deals with volumes and their relationship to a function being revolved around the axes. And we can find the volume by this definite integral, pi times the integral of the function squared with respect to x. So we want this volume. We take pi times the integral from 0 to 5 of our function squared with respect to x. So we're really integrating x to the fourth. So we need to evaluate this. We have 1/5 pi times 5 to the 5th minus 0 to the 5th, which is equal to 625 pi units cubed. So we're taking the graph of sine x and rotating one arch of it around the x-axis. One arch would be referring to that part. So we're integrating pi times a definite integral from 0 to pi of sine squared with respect to x. And to evaluate this integral, we need to look back at page 727 in the text. It's section 24F. It says the way that we integrate sine squared is we use a rearrangement of the double angle identity. And what we're going to integrate is 1/2 minus 1/2 cosine 2x with respect to x. Because this can be done using a u substitution, if we let u be 2x, then du is 2 dx. So we make this small adjustment and we find that this is equal to pi times x over 2, or 1/2 x, minus 1/4, and doing the u substitution gives us sine 2x. And now we evaluate this at 2 pi and 0. Sorry, not 2 pi, but pi. And what we end up with is that this is equal to pi squared divided by 2 cubic units. But this substitution is something that we need to make in order to integrate sine squared. One thing to notice about this problem is that we aren't rotating about the x-axis, we're rotating about the y-axis. So we need to rearrange this problem. The integral that we're going to be looking at is pi from a to b of x squared dy. So what we need to do is we need to rearrange this equation so that it's x equals instead of y equals. And y equals e to the x. Sorry, x equals e to the y. And then we also have to change the limits of integration because this is from x equals 1 to x equals e. So when x equals 1, that means that y is going to equal 0. When x equals e, y equals 1. We're just going back to this equation and plugging in our values for x. Natural log of 1 is 0. Natural log of e is 1. And we can now calculate this volume. The function squared, so e to the 2y dy. We're going around the y-axis as opposed to the x-axis. That's why we changed it to a function in terms of y. And our exact answer would be pi over 2 times e squared minus 1 cubic units. And finally, if we have two curves and the area in between those two curves is being rotated around the x-axis, we take the difference of the two functions squared. And the top function is always the one that comes first. So to figure this out, it's useful to look at a picture of it. X squared goes like so, and square root of x goes this way. So we're rotating this area around the x-axis. So to find this volume, we are going to take pi from 0 to 1 because they intersect at 1. And we're going to take the top function, which is the square root of x, minus the bottom function squared. Simplifying this, now we plug in our limits of integration. and we find the volume is 3 pi over 10 cubic units.